Hello, this is Jack Jackson. This is the first of two playlists where we're going to talk about triangles. So now that we have investigated the concepts of the foundations of geometry, length, line segments, angles, and angle measure, we're ready to start into what I consider the heart of a high school or college geometry class, the study of triangles. In many ways, triangles and their properties are the building blocks of studying most geometric concepts, particularly the study of more general polygons. If we understand triangles and their properties, then we understand a great deal about the geometry containing them. Triangles, also known as trigons, are the heart of trigonometry, which literally means the study of measuring triangles. Therefore, trigonometry may be considered a subset of geometry. And during this chapter, week in my class, or homework set, or this playlist, we will investigate triangles and their properties informally in multiple geometries. And at least the Euclidean portion of this material should be a part of any decent high school geometry class. And so high school students may benefit from many of the videos in this playlist. And this material should be repeated in the Introduction to Trigonometry portion of a high school pre-calculus course as well. So it's good for those students as well. We're going to continue to study triangles more formally in the next chapter or week or homework set in next week, and we're going to apply them in the following week. So first of all, how do we define a triangle? Well, there's one way we could define a triangle, but we're not going to actually use it in my class. It's a triangle or trigon is a three-sided polygon. And actually that's a perfectly fine definition, but the problem with that is well, first of all, it has an advantage of being very simple, and it clearly places a set of triangles in a hierarchy of geometric figures by making the triangle a type of polygon. However, this first requires that we formally define what a polygon is. And we're going to do this in a couple of weeks, a couple of playlists down the road here. But the careful general definition of polygon requires us to address several things that just do not even come up when working with triangles. Therefore, we'll use the following definition of a triangle, which does not reference polygons. Once we formally define the term polygon, we will prove that triangles are three-sided polygons as a proposition. Of course, the definitions are written so that they work in all four of the main infinite geometries that we're studying as part of unified geometry. That is Euclidean, taxicab, hyperbolic, and spherical. All right, so what definition we're going to use? Well, it's pretty simple. Given any three distinct non-collinear points A, B, and C, which do not contain an antipodal pair, we define the triangle ABC as the union of the line segments AB, BC, and CA. A trigon is another name for a triangle. Now, the part an antipodal pair, we got to eliminate an antipodal pair because if we have an antipodal pair of points, these line segments are not defined. Of course, that only shows up in spherical geometry. If you're just doing Euclidean geometry, say in a high school class, you could leave that part out. Note that the notation, like this, triangle ABC, indicates that this is a triangle, but not that it looks like that particular symbol. Doesn't have to be an equilateral triangle or any other particular kind of triangle. This definition works in unified geometry, so it might even be a Euclidean triangle at all. It might be a hyperbolic triangle, for example. The points A, B, and C are the vertices of triangle ABC. One of them is a vertex, that's singular. Okay, so vertex is singular, vertices is plural. Okay, now the line segments AB, BC, and CA are called the sides of triangle ABC. The angles, angle ABC, angle BCA, and angle CAB are called the interior angles of ABC. Now, when we refer to an angle of triangle, remember we're referring to an interior angle of the triangle. If we don't use the word interior, we mean interior angle anyway. So it's an angle, so the interior angle is a union of two rays, not just the union of the two line segments. We say vertex A and angle A, and which is a shorthand for angle CAB, are opposite side BC, and similarly for the other two pairs of opposite sides and angles. The interior of a triangle is the intersection of the interiors of the interior angles of the triangle. Notice that the interior of a triangle is a closed and bounded set of finite area, and we'll discuss these more formally a little bit later on down the line, but you probably understand what we mean there. The interior of the triangle could be uh, placed in the interior of a circle. And yeah, the exterior of a triangle is a set of points in the plane of the triangle that are not the triangle itself nor its interior. Any triangle partitions the plane that it's in into three sets: the interior of the triangle, the exterior of the triangle, and the triangle itself. So notice that the triangle does not include the interior points or the exterior points. When you construct a triangle using the polygon tool in GeoGebra, it constructs not only a triangle but also its interior. If you just want to construct the triangle, just use the line segment tool for that. For any exterior, here it is, the next one. An angle is an exterior angle of a triangle if and only if it forms a linear pair with one of the interior angles of the triangle. For any exterior angle of a triangle, the remote and interior angles are those interior angles of the triangle with which the exterior angle does not form a linear pair. So each exterior angle has two remote interior angles. And the longest side of a triangle we'll call the hypotenuse. So here's an illustration of some of these concepts here. I'm going to use this GeoGebra activity here that I have. Okay, and here we have here is a Euclidean general triangle. Notice it is the union of these three line segments, which are the sides of the triangle. Okay, a couple of things that go with that. This is the interior of the triangle, or these points here that are shaded, and it has an area. We'll talk more about area later, but right now this area is being measured by GeoGebra here. The perimeter is the sum of the lengths of the three sides. The lengths are actually illustrated there, and that's the perimeter there. The interior angles are well, there's that didn't show all the interior angles. So this is one of the interior angles here. Okay, and then we don't have the other interior angles. Let me see if I can get those going here. Okay, now here are all the interior angles. So the union of these two rays here, ray BA and BC, is interior angle ABC, or just interior angle B. And this ray here and this one here, ray CB and CA, is interior angle C. And then we have the interior angle at A, which is this ray plus union with that ray. Now, sometimes we'll just mark the angle markers there, and there are their measures. I'm in radians here, so you can see their radian measure, but I also have these things here that convert it to decimal degrees, radians a multiple of pi, and then the radians just as a decimal number there. So we can see the measures of the angles there. So those are the interior angles. We also have exterior angles, and there are two of those at each vertex. So let's just say take A here. Notice you've got your interior angle, which is going this way and this way. Okay, so that angle there gives you angle BAC. And then we have the linear pairs with that. There's two of them. One is BAI and the other one is CAF. And of course, they have the same size because they are vertical angles. Their angle markers are marked with these blue, light blue things here. And likewise, there are two angles here at B and two angles at C, which are exterior angles. We will be focusing more often on the interior angles. And one thing that's really interesting about triangles, at least in Euclidean geometry, is that if we take these three measures and add them up, there they are, it turns out to be pi radians, or 180 degrees. So that gives you a quick introduction to triangles and related parts around them.